All right, let's go ahead and get started. Hope you enjoyed that. I did see some shout outs to Johnny Cash, which is always fun. Again, I'm Jeff Henriod. I'm organizing this CTO Fellowship. We're thrilled to kick off our second session today. I'm going to spend about 2 minutes just doing a brief overview and covering a few housekeeping items. And then I'm going to turn the time over to Mike Apted, and he's going to lead the presentation today, which I'm really excited for. I think will give you a lot of practical, kind of tactical help to keep your costs down. So I wanted to remind you of the lineup. So last week, we had Ant Wilson and Caleb Hicks, co-founders of Supabase and Lambda School, talk about product roadmaps and prioritization. And that was a general conversation. It was an AMA, and they talked generally, gave a lot of great advice about how to set up your MVP, how to prioritize your roadmap for your MVP. And they talked a little bit about what to do beyond your MVP. The next 3 sessions starting today are much more tactical. So these are going to be deeper technical dives that teach you, for example, how to set up your architecture. Mike's going to go into a lot of detail about keeping your costs down, and he's going to get specific about AWS services and what you can do. Just a quick plug that next week we have Christina Cacioppo, who's the co-founder and CEO of Vanta. That's another YC company. They've had phenomenal success right now, and they automate security and compliance for startups. And she's going to give a presentation that covers all the security and compliance basics that you need to be thinking about at the MVP stage. So again, another very tactical session. It's going to be the same time next week. And then we'll round things out with the last session on the 7th of October with Jillian Ford, who's going to talk about choosing the right architecture for your startup. Just a couple of housekeeping items I wanted to reply to. So you can now view the responses for the asynchronous Ask Me Anything that we did with the AWS Solution Architects. Those responses are now in Slido. As soon as I'm done talking, I'm going to drop the link to that in the chat. Just a reminder, there's a different AMA link for today's session. I'll share that one as well. If you have questions that are specific to cost and Mike, share them in that second Slido link that I'm going to share. As always, we want your feedback. I got a lot of great feedback for the first session. I read every single word of it, and there are already things I would do differently in that session based on your feedback. So please don't hold back, share your feedback. And then finally, there have been a few questions about attendance. Last time there was an attendance link that was flying around during the session. For attendance, I actually I'll be pulling the attendance from the Zoom logs. So if you signed into Zoom today, that's how I get it. We're also going to share a survey at the end of the whole fellowship where you'll be able to indicate all of the sessions that you attended. And if there's any discrepancies, I'll be reaching out to people individually to take those on. Finally, just a reminder, to get the 5K credits, you need to attend at least 2 of these workshops. Attending asynchronously does count. And then we need you to complete the end of series feedback survey, which is what I just mentioned. We'll be sharing that after the very last session on October 7th. And a reminder, if you've already received up to $5,000 of AWS Activate credits, unfortunately, you won't be eligible for an additional 5,000. That's all I have. While Mike is starting, I'll respond to different questions in chat. I will share the Slido link for questions for this session. Please drop the questions in Slido instead of the Q&A here in Zoom. And with that, I'm going to turn things over to Mike.
Awesome. Thanks very much, Jeff, and welcome everybody. Excited to chat with you today. So we're going to focus today, as Jeff said, on cost optimization, cost management for startups, and try and help you extend your runway, do things efficiently, be effective, and sort of understand what the landscape and the options there look like. Before we get going, a little bit of background on myself. I started my first venture in the mid-90s, I guess, at this point. So if you're quick with math, you can sort of figure out where the gray hair comes from. I've been in and out of my own startups and consulting with other startups for more or less my whole life. So about 25 years of experience in that space. And then for the last 5 years, I've been 4.5 years I've been at AWS helping our startup customers in the Canadian and US ecosystems mostly sort of navigate the challenges of early stage startup life. Always interested in connecting and hearing about what you're building out and the challenges you're facing and that type of stuff. So you can find me on Twitter, you can find me on LinkedIn. Please don't be shy in sharing sort of the challenges and successes that you have, because that's sort of what drives us as a team. So our agenda for today, there are 3 key areas I want to focus on. The first is visibility. So how do you become and stay aware of your costs, your usage? How do you better understand them as well? The second is optimization. So you could maybe say, how do you get the most out of your spend? So I want to be clear that I'm specifically not saying how do I spend the least, but how to get the best return on investment from what you are spending. And then lastly, I'll talk a little bit about how do you model workload costs? How do you think about costs in the future, forecast them? How do you estimate what particular decisions may mean in terms of impact on the cost side? So before we dive into those 3 topics, a little bit on the big picture and why this all matters and how I want you to think about these things as we go through them. So first question is, why should you care about costs? I mean, I feel like there's a semi-obvious answer to that question, but you might be on credits, maybe you just took on some funding, maybe you don't feel a lot of pressure in this area. Does it even matter right now, right? I mean, I think there are 2 main areas that cause you to care about costs, and they're both important, albeit potentially for different reasons and at different times. The first one is around that idea of optimization. You want to spend less, you want to be more efficient, you want to extend your runway. These are very important factors, right? Unit economics matter. At some point, you have to reach viability as a business, and your focus will shift more and more towards this area over the long term, right? Like fine-tuned optimization is probably a problem for later, but low-hanging fruit and making sure you're making good blanket smart choices at the beginning from a cost perspective are important. So you'll just want to be conscious of an obsession around perfect optimization too early, which comes with its own external costs as well. The second reason you should care about costs is that an unexpected outcome in this area can be a threat to your business in its entirety. So you have a lot of capability in cloud, a lot of things you can do in a cloud environment. And while there are guardrails around them, you can unexpectedly consume your credits or run up a large bill if you're not watching this with enough level of detail, especially when you're in the early stages, you're experimenting, you're growing quickly. There's a lot of priorities on the table. So, make sure you treat credits like you would cash, don't waste them, be conscious of your costs, understand they're an investment in your future state. The next thing to think about is, the mentality you approach costs from, right? So how should you think about it? I just want you to always keep in the back of your mind things like buy versus build, total cost of ownership as being the way you look at things when you're thinking about costs. So not just what is the bottom number on the bill, right? But what is the impact to our business overall in the choices that we make from a cost perspective? So total cost, engineering cost, that sort of stuff. It might be possible for you to squeeze a higher level of utilization running a database on an EC2 instance, if that is something you dedicate a ton of time to. Is that an appropriate use of your time versus running a managed RDS instance? Probably not, right? So always keep in mind total cost. And lastly, when to think about costs, always from the beginning, especially when you're talking about insulating yourself from surprise bills and when you're thinking about TCO and architecture patterns and choices that you're going to make at the beginning. It's always relevant. Okay. So with that as our background, let's get into our first area of focus, which is cost visibility. There's an old maxim that says what gets measured gets managed. There's a downside to this philosophy. When over applied, you start managing things that are of low importance. But I think cost is something that you definitely want to stay on top of, right? So to manage it effectively, you need to be able to measure it and to be able to understand it. If you can maintain good visibility into your costs, you can see things like trends. You can avert those unnecessary surprises at the end of the month. You can find out about stuff early and address it. And you can use that information to inform decisions that you make, both from an architectural perspective, but also from a business perspective. So let's talk about some of the key mechanisms that are available to you to help in this regard. The first is leveraging AWS Organizations. So this means you're going to be embracing a multi-account approach from the beginning. It's okay if it's really, really simple at the beginning, one account for management and cost, bill collection, and one account for your first dev workload. But as you start to grow and as you start to create multiple environments, dev, stage, prod, different workloads that may be running in the business, maybe you have a back office batch processing workload versus a customer facing API. Accounts are good context boundaries, both for costs as well as things like security and operations. But just from a cost reason alone, it's a good reason to treat an account as a sort of container for a workload or an environment. It gives you really clear visibility into where the costs are coming from across different environments. Personal sandboxes, right? Production, you can see all those as line items on the overall bill, and it's very, very clear where your spend is being driven from. So especially, for an early stage startup where you probably don't want to get into complex tagging strategies, uncertainty around what's running in a particular account and who it belongs to, or those types of things, use accounts as your boundary, and it makes it very, very easy to see where your costs are. One more thing I would call out here is that if you're leveraging Activate, if you have credits, when the credits are applied to that root account in your AWS organizations, they will cover all the costs in the child accounts, right? So if you go and you open individual accounts by yourself, you have to manually link those all together. And if you forget to do that, it's possible that you could get a bill that isn't covered by your credits. So use organizations both for visibility, but to keep everything together in one place and make sure your credits are covering your costs as well if you're leveraging those. So the next thing you should do before you do anything else, except for maybe adding MFA to your root account, would be to set up AWS budgets and alerts. Cannot overstress this enough. The budgets console will give you a single point of reference at any time on your current and projected spend. This is great if you want to be reactive, but we want to be proactive, right? So we couple that with the alerts to allow you to be notified at different thresholds of actual versus forecasted spend. So the easiest way is to have the alert send you an email, but you can tie this into more advanced setups, like hooking it into your Slack channels and things like that if you want to. At the beginning, I would say just set up an email, possibly an alias that goes to the right people, and have the budget alerts go to that email address so that you're being proactive and you're getting notified in advance when your spend is trending or forecasting to trend above the threshold that you set. This is really, really easy to do. It takes less than 2 minutes. It's 10 steps, most of the time clicking like next or review, right? That's all it takes. I want to show you just how easy this is and how quick it can be done. So you can follow along here, either in your account right now if you want to, or you can go back to this recording and use it as a guide to step through, give you a sense of how simple this process is. So this is the management console in AWS. Hopefully that looks familiar. And at the top right menu, you'll see a dropdown that takes you to My Billing Dashboard. If you click on that, that'll take you into the billing dashboard area. You'll see a bunch of tools that we're going to talk about down the left today, right? And one of those is budgets. So if you click on that budget menu on the left, that will take you to the budgets homepage. So in this case, you don't have any set up yet. So you click create a budget. It's going to be your first one. There's different types of budgets that you can create. For your purposes, all you need to care about is the default, the cost budget, right? So what am I consuming and how much is it costing me? So leave that as a default, click next. That'll take you to the setup screen. And there's a couple of key pieces of information that we need to add here. One, we're going to leave it at monthly and we're going to leave it at recurring. So again, the defaults. And then we're going to go down to the bottom and put in the dollar amount that we care about for our budget. Right. So this is up to you. This is based on your workload. The first one, maybe just set it at $100, right? Or $200 or $50, whatever the important number is for you. Try and guess like a number that you would be surprised if you spent more than in a month and use that as your dollar amount. You can always come back and address this later. So set that dollar amount, give your budget a name at the bottom of that page, and then go ahead and click next at the bottom right. And that's it. You've created a budget. Now we're going to create the proactive part of that budget, which is the alert. So we click the add an alert threshold button that's on that page. And we put in a couple more details. One is the percentage of the threshold. So 100%, 80%, 50%, right? So you can think about sort of when do I want to know about where I am in relation to my budget. And then you can choose forecasted or actual. So in the big picture, I would recommend setting up a couple of these, couple actual, couple forecasted. But for the time being, you can just pick forecasted because that's looking as far into the future as you can, get the earliest notice that you can. and then put in the email address you want the notifications to come to. Click next, review, click next, and that's it, right? You get a final summary and you click create budget and you're done. It's set up. At that point, in the budget's homepage, you'll see something like this. So you'll see your budget, you'll see where you are against that budget, you'll see the percentage of current versus budgeted and forecasted versus budgeted. So this is something I would check in on regularly, use those email alerts to your advantage, never be surprised by a surprise bill at the end of the month, okay? So a couple other tools to be aware of. One is this is less of a tool and more of like a practice. I would get comfortable with reading your bill. So in that same billing dashboard on the left, you'll see a bills item. And you can open up either this month's bill or past month's bills. Being able to sort of, read through those and grok them is a skill that will benefit you over time. And it doesn't take too many reps to learn, but you got to do it, right? So go in and take a look at it and sort of understand how the bill is put together and what it means. Super simple structure. It's grouped together by service and then by region and then the line items for each service within that region. If you want to deep dive on this, we have an awesome lab in our well-architected labs that'll walk you through it step by step. So there's a link to that in the deck, which we'll send to everybody afterwards, and you can take a look at that. So just an awareness of how the bill is put together will help you a lot in the future. Another part of the billing dashboard that you'll want to get familiar with is Cost Explorer. So we've talked about, with budgets and with alerts, an awareness, right? A proactive awareness of what our spend is or potentially will be for the month. But that's like an aggregate, a tracking, sort of high-level tracking and awareness thing. Cost Explorer will let us deep dive. It'll let us see trends at a micro level, at a daily level, at a service level, and it'll also do some forecasting for us as well. The really powerful elements of Cost Explorer is the ability to filter and group. So to slice and dice your spend and get perspective on, how it's being put together. So this is not just sort of like how much am I spending and what am I projected to spend. This is where you get really detailed about how you're spending money within the different services. And it's super helpful for tracking down unexpected costs or for understanding even just where optimization opportunities might lie. It'll make recommendations for you. It has some pre-built reports in it, but you can also build and create your own as well. Again, there's an awesome lab in our well-architected lab setup that'll walk you through this. Just show you a quick example of what that might look like. So this is using Cost Explorer to analyze your EC2 costs. You can see on the right-hand side that we're filtering by region, or you might be able to see, hopefully, based on the size of the font, but we're filtering by region. We're limiting it to on-demand EC2 costs, and then we're grouping it by instance type. So this is giving us a really clear perspective on where our EC2 cost is being driven from an instance family perspective, right? So these are the types of deep dives that you can do into your data. Okay, so that's the visibility side of things, right? So just quick summary of the key points around maintaining visibility into our costs. One, use organizations to establish clear boundaries around your different workloads, sandbox accounts, all those types of things. So you have a very clear understanding of where your costs are coming from at an aggregate level. Then use budgets and alerts for proactive awareness of your spend. And lastly, get comfortable with your invoice and get comfortable with Cost Explorer as a means of deep diving into your trends, your spend details, and getting automated recommendations on potential optimizations. Okay. So that was category one, cost visibility. So from there, we'll move into cost optimization. So this is where we start talking about what some of the tactics are to be more efficient and to get the most out of what we're doing and how to think about making choices that will help us minimize or drive better cost efficiency. There's sort of two categories here. One is architecture. One is tools, right? So we want to do more with less. We want to extend our runway. We want to make sure we're using our credits efficiently. And the other thing is that being aware of this stuff tends to correlate well with good hygiene and performance and efficiency as well. So if you're paying attention to these types of cost decisions at the beginning, you tend to sort of build more reliable, more efficient architecture, more scalable architecture from the beginning, which is sort of interesting. So we'll talk about some of these architecture choices and some of these tools. To make this a little bit easier, I'm going to break it down by service type, and we're going to start with compute, there aren't a whole lot of workloads that we run into, especially at the early stages, that don't have some form of compute. So I think this is a sort of natural starting point. The first thing I'm going to talk about is Lambda, right? So with architecture as a key area of focus here, one thing I'll just point out is if you're starting from zero, if this is a net new initiative, one option is to embrace all the upsides you get from a serverless architecture approach. Consider using tools or frameworks like Amplify or SAM or the serverless framework or the CDK to help you build cloud native serverless architectures from the beginning. You will not find a tighter way to couple supply and demand together than with serverless to scale to zero out of the box and to get the lowest operational costs of any of your other choices, right? So if your workload supports this pattern and you're willing to invest in it at the beginning, it might be something to consider as an architectural choice. So things like APIs, ETL pipelines, background queue processing jobs, that type of stuff. If you're willing to learn a little bit, if it's unfamiliar to you, or if this is a space you've explored already, this can be a great option. And I have yet personally to meet a single customer that has migrated away from a serverless architecture for cost reasons. If you go this route, the other thing I'd point out is your work is not done. It's not automatically, fully optimized. You can still drive even more cost out of your compute by optimizing the memory and CPU slider that we give you for Lambda functions. So if you're using Lambda today and you're not using the Power Tuner, highly recommend it. Figuring out what the perfect setting is a non-trivial problem, but we have an open source tool for you. You can run it in your own account. You can decide what your priority is, cost, performance, or balance, and it'll run the full matrix of tests for you and give you the results so that you can see what the most efficient, by your standards, by your definition, option is for you when you're working with Lambda. Something to consider, right? Lambda also supports OCI containers as a delivery format at this point too, which gives it a little bit more flexibility and interoperability with other compute options on the platform. So this is not a serverless or nothing suggestion, but if this is something that's applicable to you, absolutely consider it, because it's hard to gain the benefits from this model in the other ways to the same degree. With that in mind, if completely changing your architectural pattern is unattractive or is too much of a lift to you, or just not something you have a skill set for right now, totally fine. You can gain similar benefits by simply containerizing your workload and considering something like Fargate as your compute platform, right? So if you're not familiar with it, Fargate is managed compute for container services. It's available in both orchestration systems. So whether you're using ECS or whether you're using EKS, so ECS is our container orchestration system, EKS is our managed version of Kubernetes. You can choose to deploy your data plane, right? Like you're running containers in Fargate mode, which means we manage the compute for you. So you're not managing the EC2 instances, you're not managing the patching, all that sort of stuff. So the upside I think here is obvious, right? A lot of the similar benefits to serverless, except you're working with a containerized application, which might be more familiar, more comfortable, or more appropriate for the workload that you're dealing with. But you capture some of those benefits of serverless from Fargate. They come in 50 different sizes, from a quarter of a CPU up to 4, and half a gig of memory up to 30 gigs of memory. So a lot of flexibility and choice. And you can see the real small instance types there, the real small settings, like a quarter vCPU and half a gig of memory. It's quite efficient, inexpensive to run, right? So for a dev environment, for a test environment, it doesn't scale to zero, but you're getting really close. Your costs are very, very low. And again, always think about that cost of ownership, all the security and operational burdens and all those types of things off the table. So a much lower total cost of ownership. So even if you have a simple application that was running in EC2 today, it might be worth the investment simply to wrap it in a container and think about deploying it in Fargate instead. If you are in the EC2 space, the next suggestion is to consider Graviton 2. So Graviton 2 is potentially a very easy win for you. It's an ARM-based custom CPU, custom chip designed by AWS. And sort of in aggregate across different workloads, we see it typically run about 40% better performance than an Intel-based counterpart. So that's great, right? Like you get better utilization out of the application. It's also 20% less expensive. So you can see putting those two things together starts to yield some real savings. If that's not enough, there's some green benefits to it too. It's much more eco-friendly. So that power consumption reduction is a big part of this, and it's available in all the different instance families that you're probably used to. The M families, the compute optimized C families, the memory optimized R families. Right, it's made its way now, I think, into RDS as well, and Fargate is also on the roadmap for Graviton. So this is not a 100% drop-in solution, but based on your workloads, it may be a really, really easy switch. There's some customer stories out there that are definitely worth looking into. Check out the blogs around Honeycomb if you're interested in a customer that made a big shift in this direction and realized a lot of cost savings and goes into great detail about it. It's a really interesting read. So your workload, if it's a scripting language, like an interpreted language like Python or JavaScript or Ruby or something like that, probably drop and replace, right? Just transfer one to the other. The good news is it's easy to test, right? You can spin up a Graviton 2 instance in your dev environment and see how things go. See if this is going to be a low lift solution for you to immediately chop a bunch of percentage points off the top of your EC2 bills. Also keep in mind that this is something that can be used at the data plane layer and container orchestration workloads. So if you're using ECS or EKS and managing your own EC2 and you don't want to move to Fargate, this might be an option as well. So there's implications around cross compilation of the containers and stuff like that, but depending on the size of your workload in the future, it might be something that worth investigating. Okay. And our next option for EC2, which is going to be, we're sort of going increasing order of complexity here, right? Increasing order of lift, is of course considering Spot. So if Spot is something you're not familiar with, essentially it is compute capacity in the AWS cloud that is not being used and is available to you at a fairly significant discount, oftentimes up to 70%, sometimes less. These numbers are all public. You can look them up and sort of see what the current Spot discounts are. With 70% off, pretty substantial savings. There is, of course, a trade-off for this. To get that type of discount, it means that if demand increases in the AZ that you're using it in, your Spot instance may be terminated and reclaimed, and you'll get a 2-minute warning for that. So that means there's some operational considerations here. So if we think about things from a TCO perspective again, you want this to be a significant savings to justify that operational lift, but there's a bunch of tools that sort of help with that. You can think about Spot capacity options in both EC2, on Fargate for ECS. You can build a capacity provider strategy that mixes the two together, that uses Spot for burst, that type of stuff, right? And any sort of workload that is interruptible or is latency sensitive or is batch processing oriented, that type of stuff are good candidates for Spot. So if you want really, really inexpensive EC2 based compute, take a look at Spot as an option. The last thing in our list for compute, and it's at the end for a reason, is savings plans. Savings plans are great. No architectural changes required, potentially large savings, but you need predictability in your workload, right? So for an early stage startup with a big growth curve or a lot of experimentation going on, this is something to consider. Look at the recommendations in Cost Explorer and see if they make sense. May or may not be a fit, but I want to mention it for sake of completeness. There is flexibility around it, right? You don't have to necessarily pay anything up front. There's a no upfront option. The minimum commitment is 1 year, which is a reasonably long time horizon for some startups. But be aware of this and consider recommendations from Cost Explorer if committing to a savings plan might be something that's useful to you down the road. Okay, so we're going to step out of compute and we're going to move into storage at this point. So I really only have one tip for you here. If you are using S3 in any meaningful way, so if you're storing videos in there, if you're storing large PDF files or images or binary data or unstructured data of any kind, then consider S3 intelligent tiering as a default storage class. There are several different storage classes to choose from standard down through infrequent access and that type of stuff, archive, deep archive. In the past, it was up to you to create lifecycle policies. You had to really understand your workload. You had to consider the object sizes and the frequency and all that sort of stuff, and build lifecycle policies that made sense. And a lot of startups would shy away from this because of the complexity. Recent updates from a couple weeks ago at Storage Day to the S3 intelligent tiering make it a very easy default choice for workloads without a known pattern or for any other reason, right? Like to specifically choose a separate class now. They've made a couple of updates to the way it's built and the way it's operated. There's no monitoring and automation charges now for small objects. There's no minimum storage duration. So there's really no downside if you're uncertain about which is the perfect storage class for you, to using that as your default case at this point, as opposed to standard. You're going to realize some form of savings, or potentially no form of savings, but at least it's all upside for you at this point. So if you're a big user of S3 and you have unpredictable sort of patterns of storage and you can't build lifecycle policies easily, consider intelligent tiering to help reduce your S3 storage costs. Okay, a couple tips that didn't really fit into another category, so I'm going to call them bonus tips around cost optimization. Jump into those. The first one is around data transfer. So two things I want to call out to you here. One is if you're using a CDN, if you're using CloudFront, there is, again, an option for a commitment-based discount model here. This used to be a little bit more complex, and the thresholds for commitment discounts were much higher. Now there is no threshold. If you know that you have a predictable base level of data egress through CloudFront, through the CDN, you can get 30% in savings off of it by committing to it for a year. It's not upfront, it's just a commitment over the course of the year on a monthly billing cycle. So if you reach a point where data out becomes consistent and becomes a major component of your costs for some reason, maybe you're like a social media type application, video delivery, that sort of stuff, and it will represent a substantive amount of your cost structure, then consider taking a 30% discount just for committing to your base usage level. That also includes credits for services like the web application firewall, which sort of give you a nice little bonus incentive on top of that to subscribe to that. Other things to think about from a data transfer perspective, before I leave the CDN side of things, if you're not using a CDN, even for dynamic content, something you should think about. CDN egress is cheaper than regular egress by a little bit at the beginning, 8.5 cents versus 9 cents, for example, CDN versus EC2 per gigabyte, but it is cheaper, and the discount increases as volume goes up. So sometimes just layering a CDN in front of an application, even if it's dynamic, can be helpful from a cost perspective, and there are also performance benefits to that as well. Some other things to consider when you're thinking about data transfer. One is if you're accessing AWS services from inside your VPC, you don't necessarily have to send that transfer out to the internet and back again, right? You can use gateway endpoints for S3 and DynamoDB, which is a no-cost option for accessing those services from inside your VPC. There are also VPC interface endpoints, which still represent potential cost savings over using, say, like a NAT gateway to access those services, right? So definitely something to consider if you have a lot of intra-service activity inside of the AWS platform. And then along those lines, if you're building any patterns that span AZs, which hopefully you are, because that's how you build resilient and reliable architecture. So thinking about, like, say, an EC2 compute layer and an RDS database layer, or microservices, right? Containerized microservices in a cluster that spans multiple AZs. Traffic between AZs has a cost to it. So think about that in terms of how you're architecting stuff, and think about placement strategies for your containers that may allow services within the same AZ to talk to each other, if that's an option, right, as a priority preference. Think about the way you sort of structure your EC2 and RDS positioning to minimize intra-AZ data transfer. Unlikely to be a huge cost driver in that scenario, but the microservice example can create some surprises with highly chatty internal applications. If you have a lot of different microservices talking to each other in the cluster across AZs, you may see a little bit of data transfer there that you were not expecting to see. So think about ways you can sort of architect around that at the beginning. Lastly, in the sort of bonus pile is, of course, the advice to clean up after yourself, right? So you're experimenting, you're trying stuff out, you're moving quickly. The impetus to have good hygiene inside the account can be a little bit low, but that can add up to additional costs as well. This is an area where Cost Explorer can really help you find those costs. But just think about these two sort of broad categories of resources. One would be time-based resources. So things that you don't need all the time, right? Maybe bastion hosts or development environments or experimental workloads and that type of stuff. they don't need to run 24/7. So there's a couple strategies for just turning them off, right? If you're only using them for 10 hours a day, 5 days a week, there's a significant amount of savings to be had from having them turned off at night and turned off on the weekend. Two strategies I'd recommend: one, infrastructure as code. Would strongly encourage that anyways, but when your workloads are modeled in infrastructure as code, they're easy to stand up, they're easy to tear down, right? So it could take you 5-10 minutes to stand your environment up in the morning and 5-10 minutes to shut it down at the end of the night. Potential big savings. If you want to automate that, then you can look at something like Instance Scheduler, which is a pre-built solution that we've released. It's open source. Again, you install it in your account, you tag instances, both EC2 and RDS, and based on those tags, the Instance Scheduler will start and stop them at the predefined times. So that's one way of driving a little bit of cost out without having to sort of re-architect anything, just turn stuff off when you're not using it. And then the other one, of course, is resources you're never going to use again. So abandoned resources could be unattached EBS volumes, so the storage that goes with EC2. If you choose to keep that drive when you terminate an instance, then you may forget about it, and over time you'll grow a small collection of unattached EBS volumes. Could be things like elastic IPs that aren't assigned to an instance, so they cost money when they're not assigned to an instance. Maybe you're experimenting with different patterns and you created a load balancer and you deleted the instances, but you forgot to delete the load balancer, right? Again, infrastructure as code would help you here because you bring the whole environment up and down together. But be cautious of these, like be aware of these legacy resources that may be building up in your account and slowly contributing to cost growth. If your costs are increasing and you're surprised by that because your workload isn't increasing, this can be one of those factors. Okay, so the third area I wanted to touch on today was forecasting. So what are some of the ways you can model your costs in advance if you're trying to make decisions or you're just trying to predict what's going to happen? And admittedly, this is a challenging area. So there's a couple of things I would suggest here to help out with. One, for high-level forecasting, I would take you back to Cost Explorer. It's going to give you, projections for 3 months to 12 months out based on past spend, which can be kind of interesting. So if you're sort of just looking at, organic growth or service consumption in a steady state model, but with it, increasing customer base and stuff like that, that can be very helpful. Again, also looking at the recommendations in there for optimizations. The second option for just trying to model out a workload is the AWS Pricing Calculator. You can see the URL for it there, calculator.aws. This can help you sort of compare and contrast different architecture choices, save them, share them. Oftentimes we'll have customers put something together in there and send me the link for it for feedback and review. You can compare one against the other, right? So that's one tool you can use for that. Another great option is to go to the service page website and look at the pricing page. They often have now 3 or 4, sometimes more, different examples of use cases of that service at different hypothetical scenarios and how that pricing breaks down. So if nothing else, it'll give you a very good idea of sort of what dimensions of the service and the way that it's used drive the pricing and the cost of that service. So you can sort of compare and contrast the different hypothetical scenarios and see which one seems like it's a good alignment to you and draw some inference and some conclusion from that. And then lastly, unfortunately, sometimes the best predictor of performance is performance. So you got to go to ground truth, do some experimentation, maybe drive some synthetic traffic over an architecture and see what the impact is, right? Make sure it behaves the way you expect it to in that scenario. If you understand what's linear and what's not linear about the different components of the architecture, you can use that to build reasonable forward-looking estimations based on growth, right? So if you have a sort of very linear behavior, one-to-one per user, you can sort of predict at any level of user, our cost of goods for that user is going to be roughly this. And in most situations, some component of the costing is nonlinear, below 1, right? So you're actually going to become more efficient over time as you grow. But compare those two things together and sort of use it to look forwards in the future. So we're going to wrap this up and then we can get to questions. So just remember, in summary, don't be reactive, be proactive. You want to be on top of this. You don't want anything to be a surprise, right? So we have mechanisms for visibility into that to help you with that. And it should be at the very, very top of your list of things to do. It is possible to over-optimize. Always think about total cost of ownership. I can think very specifically of an internal service operation that I took over myself on our team. And I did a bunch of optimization on it at the beginning, just out of good hygiene. And then I realized at one point I was like, spending an hour or two at a time driving like dollars a month out of the cost of the infrastructure. And so I stopped, right? Like there is a point where you should stop and focus on other things. And always think about that total cost of ownership. Like engineering effort is your most valuable resource. Make sure you're applying it efficiently. And lastly, I'll quote Corey Quinn, cost and architecture in the cloud are often the same thing. So think about the architectural choices that you're making. Think about some of the things that we talked about. Can I go serverless? Can I containerize this at least to give me more flexibility? Can I think about how I'm building an application or a microservice application across multiple AZs to just make sure that I'm taking the right steps at the beginning to minimize cost in the long run. Okay, that's it. Hopefully some of this advice is useful to you, is relevant to you, and happy to dive into some of the questions. So I'll pull up the questions.
Yeah, Mike, do you just want to pull up the questions and try to rapid fire as many as you can?
Yeah, for sure. Let me just slide, just moving some Zoom stuff around. Okay.
And then let me, and for any questions we don't get to, I can send those to other solution architects at AWS so we can try and get everyone a question if it's in the Slido.
Awesome. Okay, so let me tackle some of these. So the first one is going with container-based development. How do I keep costs low as possible for demo, for MVP, other than super obvious things like EC2? Okay, so two things I would say here, sort of going back to some of the stuff we talked about earlier today. If it's a containerized application, if it's relatively straightforward, like if we're talking API or sort of customer-facing website or even like batch workload or something like that, definitely look at the Fargate side of things, right? Because you can essentially define your container manifest, and we take care of everything from that point forward. So I would encourage looking at tools like Copilot or CDK or something like that to like really simplify the deployment process, especially at that dev and MVP stage where you don't want to be making decisions about networking and load balancers and target groups and those types of things. Just let the tool do that for you. Focus on iterating on your product. Use the real small Fargate instances to keep your costs low. Or if you want to get really, really hyper optimized, use the OCI deployment option with Lambda. Put a little shim in front of it. There's a couple of open source frameworks for both Express.js, for any sort of Python application, WSGI application. There are tools out there to shim those into Lambda. So that sort of might be an extreme optimization at that point. But I would just say use those small Fargate instances to abstract away all the other challenges and focus on what you're doing and keep your operational costs real low. Okay, next question is, what about Elastic Beanstalk? Is it a good start for MVPs or using the Docker environment possibly? So yeah, I mean, I'm a big fan of Elastic Beanstalk. I've seen it used very, very effectively. I think some great things about it are that it comes with an operational dashboard out of the box. It comes with essentially deployment out of the box, right? But you can find the same sort of advantages now across other services as well. For really, really simple container workload operation, you could look at something like App Runner, or again, you could use a tool like Copilot or the CDK to manage an ECS-based container workload and not think about all the details, right? Let those prescriptive details be decided for you. I think building containerized workloads is a little more future-proof, and using the tools that have been purpose-built for that is probably a good idea. So at this point, I would lean towards App Runner or an ECS-based Copilot deployment or CDK managed Copilot or CDK managed ECS deployment for a containerized workload. But I mean, if it's what you're comfortable with, if your core skill set is in like a classic framework, like Django or Ruby or something like that, and Elastic Beanstalk will meet your needs, it's a really, really fast acceleration process in the MVP, and that's a workload that is very easy to containerize down the road. So I wouldn't spend too much time worrying about it. I would just get moving and pick one and go. Okay, next question. Are there any downsides in future for developing cloud infrastructure tightly coupled with a specific platform? So this is obviously a very relevant question and one that we get a lot. My general feeling about this is that you are always coupled to something, right? You're always making a choice to follow a pattern, to follow some sort of prescriptive or opinionated framework or format. So I don't think there's a huge downside to using managed services, even if they're somewhat unique. Let's say DynamoDB as an example, right? Because it's just a component. It's a component of your architecture. And if you are building your applications with just a little bit of thought in the back of your mind to that, it's something that you should be able to work around quite manageably, right? And the complexity and the cost to you of sticking with something very like lowest common denominator over the long term is going to be much larger than even if you're not moving like from one provider to another. Let's say you just decide that your relational database needs to go and you want to replace it with something else, or vice versa. The cost of re-architecting, the abstraction in your application for talking to that data sync is significantly lower than the long-term cost of trying to self-manage a lowest common denominator solution in most cases, from my experience. So that's how I would think about that. Okay, next question. Some tips to control cost for SaaS startups with high scaling potential. So I think this question I would sort of reframe as like the old, it's easy to plan for failure, but it's hard to plan for success. Like what happens if, we go to the top of product hunt and things go crazy and and we just get overwhelmed. So I think if you're building with sort of modern tools, contemporary tools, so whether it's serverless, whether it's container-based, even something like Fargate, right? The scaling of the underlying EC2 instances is not your problem anymore. The scalability of an application running in Fargate is extremely high. The odds of you running into a problem there are very, very, very edge case, even if you're successful. By your definition of successful, wildly successful. So I think really the issue is more about like, I would be more concerned about sort of reliability and looking for bottlenecks or choke points in the architecture from a reliability perspective than I would from a cost perspective, because the tools you're using to build it should have at worst linear scaling cost structures and something you can assess, right, as you put it together. Anything that stands out to you as nonlinear on the plus side of one as a cost metric is something you should absolutely deal with at the beginning. And then really like your only question is optimization down the road and sort of reliability performance concerns as you grow versus cost. Okay, next question. Relational DBs are costly. Any tips on managing or reducing that? I don't know if I agree with the premise. Relational DBs can be costly, but you can squeeze a lot of performance out of a relational database. And if you look at options like Aurora Serverless or those types of managed options, again, thinking about the TCO side of things, right? No patching, no security management, no scaling challenges for you on the Aurora Serverless side. I think the lower burden there and the peace of mind, especially the upside from a scaling perspective, doesn't make them that expensive. And again, ideally, you are thinking sort of about other concerns around performance and reliability and optimization, indexing, that type of stuff, right? Like investing a little bit of money in a seasoned database administrator that has skills in performance optimization for a relational database will take you a lot further than maybe necessarily trying to like shoehorn in something that doesn't fit. So I don't think I agree that relational databases are always expensive, but yeah, just make sure you're thinking about it the right way, make sure it's the right tool for the job based on the access pattern, and maybe pull in a little bit of expertise if needed to do some internal optimization of the way you're writing queries and building tables and structuring your data. Okay. Any advice to reduce costs of NAT gateways? Yeah, so I touched on this a little bit in the data transfer area, I think, or in certain slides in the presentation. So the first thing I would say is make sure that a NAT gateway is a requirement for you, right? I mean, it is a security construct to a degree, but think about what your actual requirements are. I'm not encouraging you to be less secure. I'm encouraging you to evaluate the trade-offs of an internet gateway with very carefully managed security groups and network access control lists and other types of security mechanisms in place versus NAT gateway. If it is something that is a requirement, then start to think about, like from a security perspective, then start to think about what am I accessing, right? So is the cost of the NAT gateway that's a concern for me, the data transfer through it, or is it the hours, like the hourly charge of it running? If it's the data transfer, is any of that transfer going to AWS services? Can I run that through a gateway endpoint instead? Even a VPC interface endpoint will be cheaper than a NAT gateway, right? So can we drive traffic away from a NAT gateway would be my first question. And then if it comes down to the hourly costs, right, or even still some combo of hourly and data, my next question would be, is the NAT gateway on your critical path? So do you need the reliability and scalability of a managed service for that? Or would running, the smallest possible instance of a reverse proxy in a Fargate container, in a public subnet, or on a T3 micro or nano, graviton, possibly, right? Like the cost of running a T3 micro is going to be about 1/5 to 1/4 of the cost of a NAT gateway. Is a single, an unreliable potentially egress point sufficient for you? If it is, then just do that. But if it's an integral part of your infrastructure, I think the cost is probably something that's reasonable, and there are other areas of optimization that might be more fruitful. Okay. Next question is how to keep costs low while increasing reliability. So load balancers, multiple regions in case a region goes down. Okay. So the first thing I would say is, again, managed services, right? Focusing on choosing those types of services, Lambda, Fargate, managed load balancers, all those things. Those are regional service constructs. So the high availability and reliability at a regional level comes out of the box with those services. You don't have to think about them. They scale down quite small, in the serverless case to 0. So you get that out of the box. The next step, right, like multi-region architecture, is really something that should be driven by a business case decision. The incidence rate, I would say, is quite low, right? Like the odds of this happening to you are extremely low, historically low, and that's a business case question that you would have to ask yourself. Do we, for operational, like active reasons, need to be running multi-region? It's a non-trivial setup. There are some recent updates to different services at the networking layer with a more global approach that makes this a little bit easier. But running active across multi-regions is still a relatively non-trivial operation. And I would really press hard on like whether that's a hard requirement, because frankly, for most customers, it's not, right? So don't let yourself sort of like overreach in that sense. Just consider the risk profile of what you're architecting against, and think about the reliability that you get out of those regional services, and whether that's going to be sufficient for what you're working with. Okay. What are the various ways a new business startup can get credits with AWS? I would recommend you check out, just Google AWS Activate, or maybe Jeff can drop the link into the chat. Activate is our primary mechanism for credits to startups. You can self-register at the entry level for $1,000 in credits. And then there are more options beyond that the Activate page will go into more detail on, and then you can reach out to folks like Jeff to have a deeper conversation on that front. So I'll somewhat table that one just for now. Sort of stick with the technology stuff first, and then we'll come back to it if we have time. Another question is, how do you handle big data, terabytes per customer, cheaply and easily? So I think this question is driven largely by the access patterns. Like what are we talking about? What type of data? What are we doing with it? My gut instinct here when you talk about that volume of data is we're talking about S3. If it's binary or object-based or semi-structured data. So again, like S3 is probably your cheapest option, an incredibly inexpensive storage solution. If it's something else, we'd really have to have a deeper conversation about what the access patterns is, and the constraints that you have around availability, performance, right? All those types of things would play into that. So that would be a great question to one-on-one with an SA and have a specific chat about your workload. But generally, the answer to huge data, large data quantities, petabyte, exabyte type data quantities is S3. Okay, does AWS offer any solution for GPU-enabled Fargate? I don't believe so at this time. I would be surprised. So I believe the Fargate, the container service roadmap is public in GitHub. So you can take a look at that, see where it's sitting in the roadmap. I'd be quite surprised if it's not in there. And that would give you a sense of sort of where from ideation to we're working on it to developer preview to pre-release to release, that would be sitting in the pipeline. But yeah, it's definitely, as more sort of distributed patterns emerge, more serverless-esque type patterns emerge for different types of workloads beyond just sort of APIs and batch processing and stuff. We're seeing more and more demand for GPU in that space. So I would just take a look at the roadmap for Fargate, and that should give you a good sense. Next question. Jeff will share the recording of this with you after the fact. Let's see.
Just a new plug. I know people are worried their questions aren't going to be answered. We'll share these questions with solution architects. They will type responses in Slido, and I will share this link via email so you can see what was answered. Mike, maybe drop to the bottom of the line to give some folks that submitted down there and didn't have a chance to get upvotes in the 3 minutes we have left.
Sure. Okay, I'm going to try and keep them focused on cost as well. So one question was, what's the difference between Graviton and Beanstalk? So Beanstalk is an orchestration tool, right? It's a deployment and operational tool to help you run applications. Graviton is a type of instance. It's a type of processor architecture that we can offer at a lower cost structure than the Intel comparison. So they're two different things. Do we need to use EC2 and AWS Lambda, or either you use EC2 or you use Lambda? You can mix and match across, either within or across different workloads, right? Always like what's the best fit case for the workload that you're running. So if something is very like composable, small, function-based, event-driven, Lambda is a great option. If you need like high control over kernel customizations, right? Or very, very specific hardware, like GPUs, for example, EC2 is going to be a better bet, just based on your requirements. So always just sort of look at the requirements of what you're doing and which solution is going to fit better. Sorry, just scrolling through. Is the advice like using Lambda applicable for setting up MVP stage products for A/B testing? Yeah, I mean, absolutely. Regardless of the architecture you choose, I would say think about like, hopefully you're using some sort of tool to manage your A/B testing, whether it's client side or otherwise. So I would just sort of look at the way you intend to test that. I'll give you a very specific example for Lambda, actually. So with Lambda functions, you can actually route a percentage of your traffic to different versions of your function. So you can build, mainly it's used for release strategies, right? So you can introduce 10% of your traffic to your new version of your function to make sure it's operating correctly before you flip the rest of the traffic over. But you could absolutely use that to A/B test stuff. You'd want to think about doing it in a predictable way, right? Like making sure that a customer that's in the A frame is always in the A frame. That's usually more of a front-end concern, cookie-based situation, but there's nothing about the underlying architecture choice that would prohibit you from A/B testing in either of those scenarios. And tips for managing Aurora in an MVP state. And I'll probably make this the last one just based on time, but as Jeff said, we will make an effort to reach out to everyone and make sure your questions get answered. My advice for Aurora in an MVP, so if the upsides of Aurora are something that are attractive to you, the managed storage layer, the reliability, the read replicas, regional failover, all that type of stuff, start with Aurora Serverless. If you can. Aurora Serverless will scale to 0. I use it internally for dev and staging environments for anything that I'm working with so that those aren't running when people aren't using them. So that would be my recommendation there. Try and see if Aurora Serverless will fit within your constraints. It does place a couple additional constraints versus regular Aurora on you, but if it works for you, if you have a very straightforward use case, it's a great way to manage costs at the relational database layer. Cool. So Jeff, I'll pause there just based on time and let you take it over. I hope this was helpful to everybody. Again, reminder, feel free to reach out. Always love to hear about what you're doing and your successes and your wins. And hopefully you took something out of this that's going to be helpful to you in moving forwards.
Yeah, thanks so much, Mike. And thanks everyone who joined. I think this was a great session. Again, we'll make every effort to answer all of these questions. I'll be sharing a recording via email. I will also share the Slido link via email so you can see the solution architect responses when they come in. And I'll also be sharing the feedback survey. If you haven't already seen it in chat, please take 2 minutes, share your feedback for this session. We'll use it to inform what we do in the next iteration of the fellowship. And we'll also use it to inform other content that we create for you. So huge thank you to everyone, great engagement. Big thank you to Mike. It's a tall task to take on cost optimization in an hour. And I think you did a phenomenal job while also answering a lot of the other questions that came up. So thanks everyone, and have a great rest of the day. And we will see you next Thursday. Keep an eye out for my emails. The last thing I should say, if you have not been receiving emails from me, email me. I'll drop my email in chat. It's jhenriod@amazon.com. But if you haven't been seeing event reminders, feedback surveys, etc., send me a note. And with that, thanks. Signing off.